All right, Unit 2.3e, writing linear models. The objective is that you should be able to write a linear model or an equation to represent a real life situation. And when in algebra and in math, when we say a linear model, the word model means equation. So it's important that you know that. Sorry, y'all. Sorry, y'all. Come back to this. There we go. My apologies. All right. So let's take a minute and let's look at the slope-intercept form of a linear equation. Remember, we call this slope-intercept form because I need the slope and the y-intercept to write it. In real-life situation, the slope is the rate. However, in a few examples that we'll work with, we may not know the rate, and that is actually the thing that we have to find. The y-intercept is the starting place. On a graph, it's where the line crosses the y-axis. In real life, it's where things begin. It's where we start with the problem. Also, we have to consider time. Time is an independent variable x. 95% of the time in the problems that we model, time is the x variable. Time moves forward at a constant rate. We can't change it. It is time that changes us. So keep those in mind. Now, here are the things I need you to remember and to look for. In our study of linear functions, we have learned to write equations if we have a graph. We look for the slope m, and we look for the y-intercept b, and we just plug them into our formula of y equals mx plus b. Easy peasy. That's the easiest, I think. We've also learned how to write equations given 2 points. When this happens, we're given 2 points. The first thing we do is we find a slope. Then we use the slope and a point, and we substitute them into y equals mx plus b. We solve for b, and then we have what we need to write the final equation. If we're given a point and a slope, we can do the same thing that we did here, except that we don't have to find the slope at this point. So remember that you are able to, given these certain circumstances, you are able to write a linear equation. I want you to understand that time, we have to consider time differently and from a different perspective when we're plugging time into a mathematical equation. You may have been born in 2006, but mathematically, we consider that year 0. 2007, we consider year 1, and so on down the line until the present day. Never ever should you plug an actual calendar year date into a linear equation as you go forward to solve the problem or to create an equation. Always we start at 0 and we go forward in whatever increments of time that the problem presents to us. So let's look at this problem. We're going to use what we know to solve and do what it asks us to do. In 1990 to 2001, the number of airports in the United States increased at a relatively constant rate of 175 airports per year. There were 19,306 airports in the U.S. in 2001. So let's stop there and see what we know. I know that I have a constant rate here because it tells us a rate of 175 airports per 1 year. That is my slope, m. I know that there were 19,306 airports in 2001. Well, let's see what year that actually was, mathematically speaking. Consider that 1990, when we started, that was year 0. 91 is year 1, and so on down the line until, 8, 9, 10, and then our last one is 11. And so from here, I can see I have the point 11, 19,306. Those are my 2 points. So let's think, what do I know? I know a slope and I know a point. I need to make an equation, and that's going to help me solve this problem of how many airports there were in 1990. Well, of course, you could just go here, knowing that it increased at a rate of 175, and subtract that from this final number, and we get 19,131. I could do that again and get 18,956. But I don't want to have to do that. And what if we were talking about a span of 50 years? You certainly wouldn't want to subtract each of those and go all the way back up to the 0, which is what it's asked here. So instead, I'm going to use the point and the slope and write an equation. I'll use that to answer the question. So remember, we know that this is x, this is y, and this is m. So I'm going to plug those into my slope-intercept. Y equals mx plus b. My y is 19,306. That is equal to my slope, which is 175, times my x, which is 11, plus my b, which I do not know, and golly ding, that's what I'm trying to find. So when I do that, I'm going to plug that in. 11 times 175. Let's do that math. 11 times 175 is equal to 1,925. From here, I'm going to subtract that from both sides, and I'll discover that my b, let me do that math, 19,306 minus 1925. Sorry about the dog, y'all. That's just my Dory girl. 17,381. Sorry about that. Dory, stop. So this is my y-intercept. So I can write this here, 17,381. So I have answered the question of how many U.S. airports there were in 1990. There were 17,381. So now I have the equation. I've got my m, I've got my b. So my equation is y equals 175x plus 17,381. I can use that to solve this. It says to write it. I need to write that out for you. Y equals 175x plus 17,381. I want to find the year in which the number of U.S. airports reached 19,500. All I have to do is plug that into my equation. This is my y value. This is the number of planes. That's the y. So I'll say 19,500 is equal to 175x plus 17,381. I'm going to solve this equation first by subtracting 17,381 from 19,500. And I get, oops, let me go down here so I have some room. I ran out of space. And I end up with 2,119 is equal to 175x. Then I divide both of those by 175, and I get that x is equal to 12.1. Doesn't come out easy. I'm sorry, it doesn't come out even. But from this, I know that somewhere in year 12, well, if 2001 was year 11, then 2002 was year 12. So sometime in 2002, the number of airports in the U.S. reached 19,500. Let's look at another example. Your gym membership costs $33 per month. After an initial membership fee, you paid a total of $228 after 6 months. Write an equation that gives the cost as a function of the length of your gym membership. All right. And then we want to find 9 months. All right. So 6 months is 228. So look, I have a point. I have a point of 6, 228. I also have my rate or my slope, $33 per month. So M is equal to 33. So I'm going to use Y equals MX plus B. I'm going to substitute them in. This is X, this is Y. So 228 is equal to my slope of 33 times my X of 6 plus B. 33 times 6 is 198. When I subtract 198 from 228, I discover that B, my y-intercept, is 30. That is the initial membership fee. The place where I start is 30. Now I want to find the total cost after 9 months. Well, let's write my equation. I know my slope and my y-intercept, so I'll say y is equal to $33 per month plus the $30 where I start. So 33 times 9 plus 30 is 300, need some space here, 327 total dollars that you spend at the gym in 9 months. Let's look at the next one. A table shows the cost of visiting a working ranch for 1 day and night for different numbers of people. Can the situation be modeled by a linear equation? That's a very important question. Explain. Well, if we have a linear equation, if this conforms to a linear equation, then the one thing I absolutely must have is a constant rate of change. Or a slope. Let's see. Let's see how the y is changing. The number of people represents my x. The cost in dollars represents my y, because the cost depends on the number of people. So let's look at how y changes. Each time I'm increasing by 100. So my change in y is equal to 100. What is my change in x? My x is changing each month by 2. That reduces to 50. So it's $50 per person. $50 per person. Because this did come out such that I had a constant rate of change, to answer the question, can this be modeled by a linear equation? Yes, it can be. Finally, we're going to look at a graph. We're going to write a model, a linear model that is an equation from a graph. What 2 things do I need to write a linear model? Well, I need a slope and I need a y-intercept. This is going to be easy. My y-intercept is the point where the graph crosses the y-axis. That's 100. Let's find my slope. All right, to find the slope, I want to go along this until I find a point where it goes through a lattice, and it does there. So from here, my rise is 150. My run is, you see it here, my run is 2. So my rise is 150, my run is 2. That reduces, of course, that 150 rise over a run of 2 reduces to $75 per hour. So my equation would be y equals 75x. So when you write a model, you have to look for several things. You need to look for points, you need to look for constant rates of change, or our slope. You can plug those into different places in the model, that is the y equals mx plus b, and figure out everything that you need to know. I hope this is helpful in figuring out your Delta Math assignment. Have a great day.